Let's look at the solutions of prime puzzles, episode 20. Each of the six friends, Abhas, Varun, Charuk, Deepak, Farooq, Govinda, hold a different designation from among MD, actor, BM, footballer, consultant, doctor, with no two of them holding the same designation. Each of them lives in a different city from among Faridabad, Chennai, Delhi, Gurgaon, Kolkata, and Bombay, and owns a different car from among Corolla, Mercedes, Santro, Swift, Decor, and BMW. Each of the six cars is of a different color out of blue, white, black, yellow, green, and red. It is also known that blah, 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 blah. Basically, this is a distribution set. So let's make a table. So name, designation, city, car, and color. First row is the headings. First friend, second friend, third friend, fourth friend, fifth friend, and sixth friend. Okay. Let me name it down. Oh. So I have name, designation, city, car, and color. First is Abhas stays in Faridabad and owns a Swift. Okay. Abhas stays in Faridabad. Faridabad and owns a Swift. Okay. The actor owns the Mercedes and stays in Delhi. Actor stays in Delhi and owns the Mercedes. For exactly one of them, the initial letter of his name, his designation, his city, his car, and color of the car is the same. Let's see who that person can be. Can Abhas be that person? Of course not. Abhas already has Faridabad and Swift here, so no. Can Barun be that person? There is a BM here. There is a Bombay in city. There is a car BMW, and there is blue and black. So Barun can potentially be that person whose initials for each of these attributes matches. Let's look at Charu. Charu, consultant, Chennai. Corolla is car. But color-wise, there is no C. Color-wise, there is no C. So Charu cannot be that person. Let's look at Deepak. Deepak, doctor, Delhi, decor, but there is no color starting from D. So Deepak cannot be that person. Oh, anyway, see, Delhi is already used up, so it can't be that person. Farooq, can he be that person? Farooq can't be that person because the city Faridabad is already used up with Abhas. So Farooq can't be that person. Can Govinda be that person? Govinda, there is no designation starting with G. So Govinda also can't be that person. So can you see the only person who can potentially have all these attributes starting with the same letter has to be Barun. And we know a lot about Barun. We know these things. City is Bombay, car is BMW. The color of his car could be blue or black. We'll let that be. Next statement is, for exactly one of them, the initial letter of all the four parameters is different from the initial letter of his name. Okay. Can you see right now, Abhas cannot have the same designation, as in designation starting with the same letter as him, because actor is a different person, Abhas is a different person. Additionally, there is no color starting with A. You have blue, white, black, yellow, green, red. There is no color starting with A. So Abhas will necessarily have all his attributes starting with different colors, starting with different color. So the person being referred to in point 3 is Abhas. The person being referred in point 2 is Barun. This we know. Wonderful. Except for the above two friends mentioned in statements 2 and 3, for every other friend, exactly one out of designation, city, car, and color of the car starts with the same initial letters as their names, the pair being different for each of them. So basically they are saying one friend will have name designation matchup. One friend will have name city matchup. One friend will have name and car matchup. And one friend will have name and color matchup. Okay. For each of these pairs, there is going to be a different friend. 4 friends here, Abhas, Barun, all 6 friends have been accounted for. Okay. The person having the black Corolla stays in Gurgaon. So there is somebody with black Corolla staying in Gurgaon, which would also mean Barun has a blue BMW. Okay. Decor is yellow in color. Decor, yellow. And Santro is owned by the doctor. So Santro is owned by the doctor and isn't green in color. Is not green in color. Deepak does not own the Santro. So Deepak cannot come here. Deepak cannot come here. Okay. Now the good thing that I remember from my initial working for Abhas and Barun was that the colors were very few, as in colors and names don't really match that much. There is nobody with the name starting with R. There is nobody with the name starting with W. Blue is already assigned. Black is already assigned. Yellow is already assigned. Can you see green for somebody to have, or even when it is yellow, there is nobody starting with yellow. For somebody starting with blue, Barun is already paired up. So for this pairing, name and color pairing, which grouping would work? There is just one grouping available, green and Govinda. For the name and color grouping, it has to be Govinda green. And where can Govinda green come? They cannot come in the last row because green is not present with the doctor. The only spot where it can come is when Govinda is the actor in Delhi, Mercedes, color is green. So we have the precise location for Govinda. We have the precise location for Govinda and green. Okay. Now let's see name and designation. Who can possibly have name and designation? Govinda is completely done. Name and designation. Abhas can't be that person. Barun is already used up. Charu and consultant. It can be Charu and consultant, or it can be Farooq and footballer. That's it. Deepak and doctor is not possible because Deepak is not with doctor. So it is either CC or FF here. Charu consultant or Farooq footballer. Can't really work with it. Ooh. For city, let's see name and city. Abhas Faridabad is not happening. Govinda Delhi is not happening. Barun Bombay is already gone. Govinda Gurugram is not happening. The two cities left are Kolkata and Chennai. The two cities left are Kolkata and Chennai. So Kolkata, Chennai, and Chennai, Kolkata. Okay. So for somebody to have city and name matching, it can only happen with Charu Chennai. It can only happen with Charu Chennai because Faridabad pairing is not happening. Farooq Faridabad is not happening. And Deepak Delhi is not happening. Barun Bombay don't really care for. Govinda Gurugram is not happening. There is nobody with the letter starting with K. So name city pairing will necessarily be Charu Chennai, which would mean the name designation pairing is definitely Farooq and footballer. Farooq and footballer. Okay. So the only pairing left is name and car pairing. Name and car pairing. Nobody has a name starting with S. Nobody has a name starting with M. The BMW Barun pairing is done. Corolla, while there is Charu existing, but Charu is definitely pairing up with Chennai. So Charu, Chennai, Corolla is definitely not happening. So the only car with which you can potentially have a pair is Deepak, Decor. So Deepak here. And if Deepak is here, then it cannot be Chennai because Chennai will come with Charu. So Charu is here. Now Farooq and footballer I can put. Farooq and footballer I can put. I have made sure all these pairings are now taken care of. The only two things I'm unsure of are designation of Abhas and Deepak and color of car of Abhas and Charu. So the two designations left are MD and consultant. And here it will be consultant or MD. The color here will be white or red. And here it will be red or white. Okay, let's get to individual questions. Which of the following is true about Charu? He owns a Corolla. No. He lives in Chennai. Yes. Charu does indeed live in Chennai. The designation of the person who stays in Kolkata is the Kolkata fellow could be the consultant or the MD. We don't know for certain. So answer has to be cannot be determined. Which of the following is definitely true about the person who lives in Kolkata? The person who lives in Kolkata is Deepak driving a Decor, which is a yellow car. Okay, he owns a yellow car. This is guaranteed. Last question. What is the car that Govinda owns? Govinda owns a Mercedes. So answer is option C, Mercedes. Okay, this entire set is done. Let's go to the next one. Mankey is given a puzzle called Prime Game by his mathematics teacher. He is required to determine a single digit non-even prime number. He is required to determine a single digit non-even prime number. So this non-even prime number can be 3, 5, or 7, which is written out on one of the 4 cards, namely A, B, C, D. Okay. This and this I have to take care of. The 4 cards are lying on the table, starting from his left to his right. 3 out of the 4 cards have a single digit non-prime even number written on them. Okay, this is fun. If 3 of the 4 cards have a single digit non-prime even number written on them, can you see non-prime single digit even numbers? There are just 3 of them, 4, 6, and 8. Non-prime even numbers are 4, 6, and 8. So these 3 are there. And then let's say you have M, the mystery single digit non-even prime number. We can take the help of a supercomputer Param, which can be given a 4-digit binary code as input. Okay. The supercomputer multiplies each digit of the binary code to the respective number on the card from left to right. For example, if the computer is given 1011, so this is 1 plus 2 plus 8, 11. This is 11 as input. 11 in decimal and 1011 in binary. If the computer is given 1011 as input, then it completes the multiplication in the following order. 1 plus blah, 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 blah. 1 into A plus 0 into B plus 1 into C plus 1 into D, where A, B, C, D are single digit distinct numbers written on cards A, B, C, D respectively. Okay. The supercomputer then gives the above output in the decimal notation. Okay, the result comes out in decimal notation. The input is in binary. Cool. Mankey can see both the input as well as the output on the supercomputer. In case an input has less than 4 digits in the binary system, the prefix appropriate number of 0 to make the input a 4-digit number. For example, if an input is 1, 1, this is not 11, this is 1, 1, or this is the number 3 in decimal notation. If an input is 1, 1, then consider it as 0, 0, 1, 1. Okay. First question. This question is about your familiarity and comfort with base systems. First question. One of the options below shows the set of values in decimal notation whose binary equivalent as input to the computer would be sufficient to determine the prime number written on one of the cards. Which of the following is the required set? Okay. So look at the first grouping itself. This is fun. 1 in binary will be written as 0, 0, 0, 1. 2 would be written as 0, 0, 1, 0. 4 would be written as 0, 1, 0, 0. And 8 would be written as 1, 0, 0. If all we are doing is multiplying it, from the first input, we are going to get D as the outcome. From the second input, we are going to get C as the outcome. From the third input, we are going to get B as the outcome, precise outcome. And from the fourth input, we are going to get A as the outcome. We will precisely know what is A, B, C, D. We will know precisely what is A, B, C, D. And if we know what is precisely A, B, C, D, we would know what prime number is present. We know 4, 6, and 8 was there. And the fourth number, whatever it gives me as a result, that will definitely be the result. Let's say if we had 7512, I will also do it for an alternate set. Let's say we had 7512, 7 in base 2 notation is 111. Okay. 5 is 101. We need 4-digit numbers, no? Okay. 1 is of course 0001 and 2 is 0010. This will give me B plus C plus D. This will give me B plus D. This will give me D, and this will give me B. Can you see? You would be able to uniquely identify C from here. From the first two expressions, you would be able to identify C. From the second and the third expression, you would be able to identify D, and you would be able to identify B. But A will still remain a mystery. And what if A is that prime number? What if A is that prime number? Then you would still not be able to identify the prime number written on one of the cards. So option 2 is not sufficient. Similarly, I will go through every option just to assuage people who will have confusion in this, because anyway, the problem here is if you don't understand binary and base system, then regardless of how much processing I do, you will not understand this. But let me try for those of us with partial understanding. 3 will be 0011, 2 will be 0010, 1 will be 0001, and 4 will be 0100. This will give us C plus D, this will give us C, this will give us D, this will give us B. Can you see A still remains elusive? We will not be able to identify A. Okay, and 3312. Let's go 0011, 0011, 0001, 0010. This gives me C plus D, this gives me C plus D, this gives me D, this gives me C. I don't even get A and B here. So I will definitely not be sure of what that prime number is on the fourth one. So my life is settled. Answer to the first question has to be option A. Question 2. If Mankey sends the binary equivalent of 15 as input to the supercomputer and gets 25 as the output, then the prime number thus obtained by Mankey is, okay, see, 15 was sent in. 15 in binary is 1111. Yes. So the output of this would be A plus B plus C plus D. Output here is A plus B plus C plus D. Now this, out of these A plus B plus C plus D, we know the 3 digits are going to be 4 plus 6 plus 8. So we have 18 plus M, that prime number is equal to 25 according to the question. So that prime number has to be 7. Answer to the question is option D. They're not asking me unique values of A, B, C, D. They're asking me for what is that associated prime number. Associated prime number I can identify. Next is if the number written on card D is 5. Okay, number written on card D is 5. And the decimal notation of the input is 14. Decimal notation of the input is 14 translates to 1110. Okay, D is 5. Then which of the following is the output? Here I would get A plus B plus C, because D is that single digit prime number. So A plus B plus C has to be 4 plus 6 plus 8 in some order. We don't know precisely what that order is, but their summation I know will turn out to be 18. So answer to the third question is option D, 18. Last question. If the input is 13, then the value of the output cannot be more than. If the input is 13, input is 1101. This is the input. Then the value of the output cannot be more than. Now see, we are trying to maximize our case. We know 4, 6, 8 have to be distributed and 7 has to be distributed. The 4 digits you want are 8, 6, 4, and 7. These digits we need. So where do I place which ones? Here, because it is 8, large one. Here, because it is 7, large one. Here, because it is 6, large one. And here I will place 4 because it is the smallest one. When I multiply, I get 8 plus 7 plus 6 adds up to give me 21. The value of the output cannot be more than 21. Now, the only number that you can effectively change here is this. If you had 5 here, the sum would turn to 19. If you had 3 here, the sum would turn here to 17. But the maximum sum that you can get is 21. And that is the answer. That will be all for this episode. Hopefully you learned something. Okay, bye.